Good morning, everybody. Thank you all for being here this morning. Welcome to our last First Friday for 2022. I'm Bert Jackson. I'm the CEO of the Cape Cod Technology Council. This is really booming in here. So thank you all for being here. I'm thrilled to have this presentation today. This is very close to my heart in terms of where we're going as a community and as a society. And I think that what Dan and his crew are doing is just amazing and very cutting edge, and I can't wait to hear about that. Just a couple of quick things. I do want to give a huge shout out and thank you to Cape Cod 5, Matt, Maggie, Michael, Andrea, everybody who's been helping out here today to put this and host this here. So thank you very, very much. We actually had a First Friday about this building in November of 2019, right before they opened, to learn about all the cool things that are happening here. I think, Matt, maybe we should have maybe a Q&A about this at some point in the near future to tell people about what the use cases have been now that you've had the building here for a few years. It's very cool. You can control the tint in the windows with your phone. It's really cool. Also, a big shout out to Open Cape, who has been our First Friday series sponsor for 2022. We really very much appreciate that. Steve Smith is in the back of the room. If you have questions about Open Cape, you can do that. Our January First Friday, location to be determined, we're going to be having speakers from the Cape Cod Climate Change Collaborative talking about the work that they're doing. It all ties in together with renewable energy, electric airplanes, electric vehicles. It's all part of the same ecosystem, and there's so much that we can learn about that. And they're doing some great work on the policy and the promotion end of that. So you can hear about some of their work as well. So with that, enough of me. I'd like to introduce our program chair, Grace Terry. Grace, there you are, who's going to tell us about our speaker today. Grace?
Thank you, Bert. Good morning, everybody. It is wonderful to see so many people here in person. Again, thank you to Cape Cod 5. This is gorgeous, absolutely gorgeous. Our speaker this morning is Mr. Dan Wolf, Chairman of the Board of Cape Air. Disclosure, I work for Cape Air and I love my job, so no pressure whatsoever. Dan founded Cape Air and flew the inaugural flight in 1989 for Boston to Provincetown. As CEO, he built a phenomenal company and a superb airline. Dan was also the airport manager of Chatham Municipal Airport, where he was an aircraft mechanic and a flight instructor. So a little bit of a theme here, right? Pilot, aircraft mechanic, founds an airline, CEO of an airline, chairman of the board of an airline. To say Dan likes aviation is an understatement. Dan loves aviation and planes and fuel caps and all sorts of things. So he's rightly recognized as a leader in the industry, a visionary in the industry. Dan's been on board, with e-planes before people knew about them, before people were talking about them. Dan was driving them forward and literally instrumental in, here we go again, getting them off the ground. I'm sorry. Dan is a leader. He's a leader with heart. A very big heart. He has a collection of well-deserved and well-earned awards for humanitarianism, philanthropy, protecting the environment, community service. Dan was state senator. He served 3 terms from 2011 to 2016. And I'm going to stop talking because Dan is a fantastic speaker and storyteller. Please give a warm Cape Cod Tech Council to Mr. Dan Wolf.
Raise your hand if you can't hear me without the mic, because I have a tendency when I get nervous, which I am, to yell, and then if I have a microphone, people run out of the room. So I'm not going to do that. I want to thank Grace, who totally revolutionized what technology means at Cape Air. When we started Cape Air 34 years ago, I remember when somebody brought in this big tube thing with a green blinking dot on it, which all you guys remember, and there was what was our word, the word, it was like a word perfect. Does anybody remember that? And then somebody came in and said, we have this program, and they wheeled it in a box, and it was called Lotus 123. And before that, technology was a fax machine and a telephone. Honestly, I remember early on, all day I was on the telephone. And I go weeks now without ever even picking up my telephone. In fact, we just upgraded our telephone system, and I asked Grace, why are we doing that? No one uses telephones anymore. But it's a great intercom system, and it's a wonderful thing. But a great name appropriate to bring to Cape Air, because nobody does it better than Grace. This is, and the rest of the technology, Kurt is here, Matt is here from Cape Air. We have just a splendid technology department and function at Cape Air. This is like incredibly weird and incestuous for me, because Grace, who is your program director at the Technology Council, gets to introduce me. I'm speaking in a building. I've served on the board of Cape Cod 5 for 18 years. In fact, those who are like me with the gray or the loss of hair remember a guy named Elliot Carr. And his last board meeting as CEO of Cape Cod 5 was my first board meeting going on the board of the 5. That's how long I've been with this organization. But so I'm embedded in this organization. I spent a lot of time in this room. I want to thank Matt Burke, who is here, the CEO of the 5, for welcoming us and for giving us this incredible venue, because I'm sure you have a waiting list of organizations that would like to come here and speak. And I want to thank you for your hospitality. If you work at Cape Cod 5, raise your hand, if you would. So we have a great representation from the 5 as well. And then the Climate Change Collaborative, who is, I guess, coming to your next meeting. My brother Jim Wolf is one of the founders of that. He runs the sustainability function at Cape Air. He's the director of sustainability and was one of the founders of the Cape Cod Climate Change Collaborative. Dorothy Savarese, who is the former CEO and executive board chair here, is the president of the board of the Cape Climate Change Collaborative. See what I mean? We're talking about, now I'm so confused I'm going to sit down. I hope you enjoyed this as much as I did. So there's a lot of, the neat thing about Cape Cod is there's enough overlap so that we really take each other's synergistic energy, and we know and trust each other as people, and we share a love of this place and a love of the environment and just so much enthusiasm and energy. And it all comes together here this morning. So I think the theme for this morning for me, I'm going to give you a little bit of background of the airline, because I think what we're doing with the electric airplane is really only meaningful in the context of what the airline has done, certainly over the last 12 or 13 years, relative to understanding the impact that we have on the environment and what we might be able to do about it as leaders. So what you're going to get this morning, because I don't have 45 minutes about electric airplanes because it is that cutting edge, is a little bit about the airline and what we are doing about the impact that we're having on the environment, and then also about the electric airplane. And you're going to see history made. The largest all-electric airplane ever flown is the one that is being built for Cape Air and, of course, others. And it was just flown 2 months ago. So that's how cutting edge this is. We're going to talk a little bit about the certification process too. So I'm going to go through the presentation and then love to, what I really liked, and I liked it in politics too. A lot of times politicians will make a speech and then scurry for the door. The favorite part about me in public service and in environments like this is to really have it be interactive. So I'm going to try to get through the presentation fast enough to give us some time. How many hours do we have? So that we have some time at the end to actually have some Q&A. If you need me to stand up here, I will, but when I stand up there, I feel like I'm making a speech, and I hate that. So there's that. Oh, sorry. Does that mean I talked too long? Yeah. There. Okay, so Cape Air, as Grace said, we started scheduled service in 1989. The first flight was between Provincetown and Boston. I actually flew it. I had Gary Studs, who was our congressman at the time, in the right seat, and I was so nervous and so engrossed in talking to our congressman that I actually got lost on the way between Provincetown and Boston. Which, if anybody is a pilot here and you think of the geography, how could you possibly do that? But fortunately, I was talking to air traffic control and they helped me. In the right seat of the airplane here is Linda Markham, who is now the CEO of Cape Air, the only female CEO of an airline in the United States. So that tells you something about Cape Air. It tells you something about the state of where we are with trying to get to gender equality. That's sort of shameful, but we are blessed to have Linda as our Chief Executive Officer. The transition happened in January. The bank has also going through a transition. Matt is relatively new CEO here. And those transitions are fun and interesting and energizing, and Linda does just a fantastic job. We started with one airplane and me as the pilot and the mechanic. It was really, who's seen the show Wings? Remember that show? So that show was modeled off of Cape Air. The producer of that show actually was a customer who had a place on Nantucket and flew back and forth on what was then Nantucket Airlines, which became part of Cape Air, and actually came up with the theme for Wings from doing that. And I think he modeled the character Lowell after me, if you remember Lowell. he was the mechanic. But in the years since 1989, with that one airplane and a handful of mechanics, Cape Air has grown significantly. We are the largest commuter airline in the United States. Commuter airlines are licensed under a set of regulations which is slightly different from what the big major airlines are. So commuter airlines are in a set of regulations that Cape Air is now the largest. We operate over 100 airplanes. I'm going to show you our route maps in a minute. And we did an employee stock ownership plan in 1995. So we've been an ESOP company for 27 years. And the amount of ownership owned by the employees sort of varies over time, because unlike Enron or Avis or United, who did ESOPs that were really a tool to work through tough financial times, Cape Air did our ESOP because we wanted to share the success of the company with our employees. And part of doing that is making sure that your employees have liquidity. We're going to talk banking for a second. And are not trapped into the stock of the company. But we have always given our employees the ability to sell their shares and roll those proceeds into the 401k, into the retirement plan. So the amount of our company that is owned by the employees really changes over time. A few years ago, we bumped it back up again, because over time, as employees retire and sell their shares, they go back into treasury. But we are an employee-owned company. And I think as important as being employee-owned relative to the financial side of it is the management ethos culture that it creates, which is a lot of frontline employees who really feel empowered and feel ownership and participate. And I'm looking at Kurt Curry here, who is one of the best examples of what the Cape Air culture is all about. Just the amazing spirit, philanthropic, how you think, Kurt, is just an amazing thing. So Cape Air is an employee-owned company and has been, as I said, for 27 years. Linda Markham at the helm. If I push the wrong button, will you run up here and push it for me? Yeah. Any airline, safety is first. The picture there is our new Italian airplane. We started getting these about 3 years ago. These are not electric. We needed to, the mainstay of our fleet, we have 70 Cessna 402s. Those airplanes were aging. So that until we get the electric airplane, which, as you're going to hear, is a few years off, we had to bridge that gap. So what we have done is we have taken 30 airplanes from a manufacturer in southern Italy. Has anybody here traveled to southern Italy? Why would you do business with a company in southern Italy? No one in the United States would actually build a good replacement airplane for us. So this is the same capacity as the Cessna 402, which you saw in the previous picture. But we are currently refleeting with that. Safety is always first in an airline. Our sort of three pillars are sustainability, growth, and innovation. Sustainability there is a double entendre, because we believed in sustainability before we believed in sustainability, which is you have to have a business model that actually is going to be sustainable. In our industry, it means surviving recessions, surviving horrible incidents like what happened on 9/11 20-some years ago. But it's an industry where I am proud to say that I think, other than Cape Air and Southwest Airlines, I can't think of another airline in the industry that hasn't gone through at least one, if not multiple, bankruptcies, or gone through consolidation and disappeared. Remember, Eastern Airlines, Continental Airlines, Northwest Airlines, US Airways, all of those disappeared. And the major ones that still exist, who would that be? United, American, Delta. JetBlue is too young to have gone through a bankruptcy, but all of those have gone through restructuring and consolidation. Because of the way we've run the company financially, we are a sustainable company and a stable company. We always look for opportunities to grow, because part of the culture that keeps employees like Kurt and Grace and Matt engaged is they want to see opportunity and growth, and we do that. And then innovation, which we're here to talk about this morning. Our niche, and I think we do it better than anybody in the world, and it's powerful to say that, just like I think, and I'm not blowing smoke, Matt, I think this bank does what it does better than any financial institution in the world. I really mean that. Cape Air does what we do better than any airline in the world, and what that is understanding our niche, which is short haul, small community air service, very often in geographically challenged places. Because if you have a road that goes 22 miles, it's hard to compete by air. But if it's an island, it's easy to compete by air. So we have looked for niche opportunities where that type of high frequency short haul service really works. That's an important niche when you think about electric airplanes, because the limitation on airplanes, given battery density and some of the other technical challenges, mean that where it's going to be launched first is small airplanes, because the physics works better, short haul, because batteries don't take you that far, right, and high frequency, because you got to utilize the equipment. You can't fly it a half an hour a day and have it pay for itself. So you got to have a lot of frequency moving the airplane, but it can't be going long distances. And we're really the perfect launch customer for that. And again, the Tecnam P2012 Traveler is the Italian airplane that we are currently putting into service. And you haven't seen them much around here, because the first market that we put them in is our Midwest markets, which I'm going to show you about in a minute. One of the things to be a successful airline to small communities is, if you look at our route maps, you'll see Chicago and San Juan and Boston, obviously, and hub airports. And in order to do that well, you have to integrate yourself as an airline into the global distribution system on the business side, and you have to have the relationships with the major airlines on the operational side, so that you can buy a ticket online connecting Cape Air to any major airline on one itinerary. And then when you get to the airport, you can check your bag with us or with them, and the transfer is seamless. I say that smirking because I look around always to say, when that bag transfer is seamless, I always look for faces and say, really? but it actually is, and we do a lot of work to integrate globally. So, when you go online at any of the global distribution systems, whether it's another airline, whether you go on United and make a ticket with Cape Air, or whether you go on Orbitz and make a ticket with Cape Air, it takes a lot of work. And again, kudos to our IT department to make those connections in the IT universe, so that you can buy that, purchase that product, and make sure that your bag is going to actually connect to the right airline and go to the right place. It takes a lot of work. And then on the airport side, your bag arrives on American Airlines, it somehow has to get to the Cape Air baggage area, get onto our airplane and go where you're going. Vice versa, if it goes up on Cape Air, it's got to transfer. And so on the operational side, you've got to have that facility as well. So we worked really hard over the years to integrate into the global transportation network, which means interline agreements, co-chair agreements with the major airlines, and then putting ourselves out there in the distribution universe, so that you can buy the tickets easily. And again, Matt, we talk about a bank that's got to have a couple $1 billion, or $500 million at least, $500 million of assets to actually have critical mass to invest in some of the security and technology and regulatory compliance. The same exists of airlines now. We started with one airplane 33 years ago. It would be really hard to do that now because of the scaling of it. And that really is around technology. When you make the investments that we've made to be as integrated as we are, it's a big hurdle to do that. And then from a compliance standpoint, just like any industry, compliance has become more complicated. And we're going to talk about that when we talk about how we get the electric airplane to market, because there's a lot of compliance issues with that. So we are fully integrated. Part of our innovation is not just getting electric airplanes, but it's investing in the next technology platform that's going to get us there. There's our route maps, as I talked about. You can really see sort of what our business model is on this, because it's a lot of hub and spoke there, right? If you look at Boston, we started with that one route, Provincetown, Boston. Our expansion over the next number of years is really around the Cape and Islands, In 1993, we started service in a counter-seasonal market, but it's not even on the map, Florida. At one point, we actually served 9 cities in Florida. We were in Miami, we were in Lauderdale, we were in Fort Myers, and we served a lot of small communities down from, from Key West all over the state. We're not in Florida anymore, and that's because it's too easy to drive an automobile at a really high rate of speed around the state of Florida, and we actually moved the assets to where it works better. Where we have expanded tremendously is in the Caribbean, and in these markets, we're the biggest carrier. And who's flown us in the Caribbean? Okay. The neat thing is that new Italian airplane actually has air conditioning. What a breakthrough. So when we get that down there, you'll actually be able to fly in air conditioning. And Katie Service is here. She runs the Cape Cod Gateway Airport, so Katie just waved to everybody. And has emerged as a leader in this revolution that we're talking about today. The Cape Cod Gateway Airport, relative to the size, has more solar renewable energy on it, I think, than any airline in the country, just an airport in the country, relative to the size of the airport. And Katie has been a great partner, a thought partner in helping us understand how we're going to launch this new technology, because it's an airport component that's just as big as the aircraft component. Anyway, those are our route maps. Where we have put the 30 Italian airplanes, attacked in 2012. So far, it's really in the Midwest. So we have a base in Chicago, we have a base in St. Louis, and we have a base in Nashville, Tennessee. And that's a real challenge. Putting my banking hat on sometimes, got to keep doing this because we're in the bank, and I got to keep doing the bank analogy here. But I look at that route map, and Matt, imagine having a branch in every one of those cities. It is a huge challenge to have that geographical footprint that we have, but it's a pretty cool route map. And one of the neat things about having that kind of footprint is culturally to the company, it exposes us to cultures that we never would have been. So when we just did Provincetown, Boston, it was sort of a bunch of Yankees flying between 2 places in New England. But as we've spread our wings, we've really sort of embraced cultures from. I sometimes wonder, which is a more different culture than here, whether it is St. Croix in the Caribbean or whether it is Havre in Montana. It's just been an amazing journey, though, from that regard. The sustainability part, I will never forget a phone call I had with my brother Jim. He was living in Montana at the time, and this would have been, in like 2008? And Jim called me up to say the world is running out of oil, and you're screwed, bro. Seriously, that was the conversation. I remember where I was standing at home saying, he's like in some cult out there. But where he was prescient is that it's not that we're running out of oil, but we're certainly running out of the ability to continue to use oil the way we always have. And you hear a lot of the climate change people saying, the most important thing we can do going forward is to leave that oil in the ground. So what Jim did convince me is we need to get our head out of the sand and understand that as an airline, we're burning fossil fuel. Climate change is a real thing. Pollution is a real thing. And he sort of like climate shamed, environment shamed his younger brother. I am his younger brother. And we decided at that point to really start to invest in, understand, and move forward with how to be a sustainable airline. And the optics of an electric airplane, that's really kind of the sizzle part, right? It's like, wow, you're going to use an electric airplane. But the real heart and soul of sustainability goes through the entire organization to everything you do. And so I said to Jim, if you're willing to put down the grizzly stopping gun and get on an airplane and come to Massachusetts, we would love for you to run our sustainability department. So Jim has been on board with Cape Air since 2009, right? And running our sustainability. And in doing so, we really were the first airline, we're not the biggest airline, that came up with a mission statement around sustainability and then started to implement both big and small projects. Obviously, the biggest is the electric airplane, or will be. But we have done a lot of stuff to the point that in 2012, I got the honor of walking out of the Capitol, Beacon Hill, as a state senator, down the hill to, I think it was Faneuil Hall, where they actually had a ceremony, the EPA, federal agency, was recognizing Cape Air in 2012 for the work we were doing about sustainability. And that was a huge honor to get a federal recognition like that. As Grace said, we started looking to electrify this before I actually understood and knew what the challenges were. Just about every great technology breakthrough or innovation has to do with somebody coming up with an idea and not realizing how impossible it is, right? And they just get it done. So, we didn't understand how hard it was to make an electric airplane, the physics of making an electric airplane fly. In 2016, we started conversations with a company that was then located in Tel Aviv, Israel, now located in Seattle, Washington. They came to us and said, we're looking at getting into electric aviation, and we're thinking about a 6-passenger airplane. What do you think? And we immediately got back to them and said, 6 passengers doesn't work, because the regulatory environment that we operate in is 9-passenger. And if you build a 6-passenger airplane, as soon as somebody builds a 9-passenger airplane, your airplane will be obsolete. So they thought about that and said, you know what, it's a big step from 6 seats to 9 seats, but we're going to do that. And we convinced them back in 2016 to invest all of their efforts into building an exact replacement airplane for Cape Air, which is 2 pilots up front and 9 passengers in the back. And that conversation's been going on now for more than 6 years. And then, as I'm going to talk about in a sec, a bunch of other things we're doing internally to really support the concept around sustainability. I think the coolest thing we did, so we built what at the time was the largest solar array in southeastern Massachusetts. How many, big is that?
258, a quarter of a megawatt.
It's a quarter of a megawatt. Think about that now. That wouldn't even move the needle now, right? Somebody wouldn't, what's the big deal? Back then, it was the biggest solar array that had been built, and the original cost was about $1.3 million. 1.3 million. What did Cape Air pay?
Well, because we were early, we got a lot of help from various governments. So
Right.
it was like almost paid for when we turned it on.
We didn't even rehearse this morning. but of the 1.3 million, I think Cape Air's investment was about 300. Is that about right?
More like 150.
Yeah. And so, the reason I say that is it really is important when you're launching a new technology to see it as a public-private partnership. And the same exists with the airport infrastructure, same exists with the operator and the manufacturer of these airplanes. We're going to need to do this in partnership with the federal government. So we did this solar array. The Cape Air investment was to find somebody who was capable of putting all the pieces together, getting the financing and getting it done. Now that generates, what, about $110,000 worth of electricity a year, something like that?
Depends on if you're talking last year or this year, because electricity is 50% more expensive.
So from now on, when I ask you a question, just go, yeah. Does anybody remember the Smothers Brothers? So at some point, we do a Smothers Brothers thing, so we'll come back and do that at some point. But this thing now is generating enough electricity so that it is paying for the Cape Air portion in about every year and a half. It pays back the original investment. Think about that. We've had it up there. It's probably the most profitable thing that Cape Air does, actually, is let the sun shine on our roof. Since then, and we're net zero at our headquarters where we do all our heavy maintenance and we have our administrative offices and all these computers and everything, eating electricity. We are generating more at our headquarters than we actually use at our headquarters. And so we are a net producer. Since then, under Jim's leadership, we've done 2 other significant solar projects. One on our administrative building where we do a lot of our HR function. And then we did the other half of the big roof at our big hangar. So we've done 3 fairly significant solar projects there. We're looking for more. How about a carport? Yes.
Yes.
And we're all into that. By the way, the commitment here, you all noticed the other floor that they're building on the parking garage because we need more parking spaces. No, it's actually going to be solar, right? And Matt, when is that going to be done?
A few months.
Yeah.
It's taking a while. So steel obviously held us up a bit, but part of the original plan. But glad to get it done. Gets us close to net zero here.
So this building will be net zero. It's a LEED certified building. Great corporate leadership in that as well. One of the things, and it's not up here, my favorite anecdote about this, because it does get to the big and small. After we did this, Jim said, you know what I'd like to do next is I'd like to give each of our employees 3 light bulbs. And I said, yeah, you gotta be kidding. 3 light bulbs? And this is back when light bulbs were that, fluorescent thing with the loop. And I said, well, why would we do that? And he said, Dan, if we give each of our employees 3 light bulbs to take home, and they use it, I'm not even gonna ask, a certain number of time a day, it actually will have a greater impact than the solar array we built on the roof. And the reason I say that is because the little things add up to be really big things. So we distributed 3 light bulbs to each of our employees, and the impact that is having is remarkable. So we do a lot, as does this institution, as far as supporting our employees relative to this. So we have helped coordinate home energy audits. We currently subsidize our employees to buy electric vehicles. I drove here today in an electric vehicle. We help and support our employees in getting more energy efficient appliances at home, and the list goes on. And we do the same thing in the communities we serve too. So, when you have the ability to have a footprint that goes way beyond the actual core business you're in, it can make a huge difference. The lighting, and you can see, this is embarrassing because one would think that we used to do our maintenance on our airplanes in a dark hangar. But I will say that when we actually got the new energy efficient light bulbs in the hangar, our mechanics would come into my office and say, God, it's great, I can see out there now. And I'm thinking, but it really has made a remarkable difference. And how much reduced by 80% the consumption of the light?
60% on the lighting, yeah.
Yep, see?
But
Like I said,
did want to say
80%.
one thing.
Go ahead.
Your favorite anecdote?
Yeah.
Those light bulbs that saved our employees about 350,000 kilowatt hours a year that whole program cost about 15 grand. Whereas the solar that made 350,000 clean cost 1.3.
Yeah.
So that's why the little things count.
Little things count. And then the other thing we did, because we do burn carbon fuel, is we look for ways to take our old airplanes and apply modern technology in fuel savings. So we modified our engines, we put much more precise fuel gauges in them to really measure how we do fuel, and save over 100,000 gallons a year just through doing that measure, which again not only reduces expense and pays for it. That project actually paid for itself in about 4 months, converting the entire fleet to save fuel. That's how expensive fuel is. And then, as I said, we do a lot of things both internally. This is a weird picture because I don't know how I made it into this presentation. That's actually a turtle. And what we're doing there was we rescued a turtle and we flew it somewhere. I'm not sure where we flew the turtle. Where did you fly the turtle?
It was an injured turtle that had been nursed back to health on St. Thomas and needed to be released at its natal beach. And they asked us to fly it there.
That's the corporate side, actually turtle soup. So we signed an LOI for the first 75 of these incredibly beautiful airplanes. Aren't they just extraordinarily beautiful? The technology of making these airplanes, they're basically designing an airplane that you can make in a 3D printer. That's exaggerated, but our airplanes, traditional airplanes, are made out of aluminum and riveted together, and some of the surfaces are bonded, but it's a pretty conventional manufacturing process. This is a very new manufacturing process. A lot of those components on the airplane are composite components. They're not made out of metal, they're composite. And that's a real breakthrough as well. For the weight, the strength of a composite can be much stronger for the given weight, which obviously in an airplane what you're trying to do is save weight. So this is what the design now looks like. The first design that they came to us with had an electric motor on each wingtip and an electric motor pushing back on the tail, which, that was great for aerodynamic reasons and for a lot of other reasons, but when you try to land an airplane in a crosswind, you need to lower one of the wings. And when you have the electric motor and propeller on the wingtip, So, you know, we've had to work through some iterations about what will and won't work. And when you put a motor on the tail pushing back and you land an airplane, if you've ever noticed when you land an airplane, you raise the nose. Well, when you raise the nose, what happens to the tail? So they actually designed an airplane that every time you landed, you would wipe the motor off the tail and off of one of the wingtips. So over time, they developed it. Okay, let's put the electric, let's go from 3 motors to 2, and let's put the motors out on the tail section, on the empennage, and let's have them high so that there's not a ground issue. And if you notice, you know, one of the reasons you do a T-tail on this is to get the horizontal stabilizer, this aerodynamic surface above where the slipstream from the motors is, because you don't want to be blasting your aerodynamic surfaces with that. Is this one, is the next thing? No, you got it. Okay. So what you're about to see, we went back and forth on whether we should show this clip, but you got to see this clip. Okay. This is aviation history. To me, this is as important as watching the Wright brothers' first flight. Oh my God. I do get chills when I see that. The largest all-electric airplane ever to fly in aviation history. Where was this? This is Moses Lake, Washington, and just a couple of months ago. They didn't want to bring the landing gear up because they didn't know whether it would come back down. That's pretty cool, huh? So Katie, how about a fleet of those?
I love it.
Yeah. So a little bit about it. And I'm just going to go down and talk about sort of how it relates to what we're flying today. Our airplanes today fly around, the maximum speed is about 190 knots. Again, the conversion is about 1.2. So if you want to know how many miles an hour that is, just go whatever I say times 1.2. So this airplane goes 260 knots, 300 miles an hour. That's at maximum power. We're going to use the airplane. It's going to cruise for optimal energy consumption at about 160 knots. Our current airplanes fly a little bit slower than that, but that's pretty much the same. The day VFR is what you would fly on days like this. You're not flying in the clouds, you're not flying on instruments, is about 250 nautical miles. When we first started talking to them, they had promised us 450 miles. So you can see, as reality starts to weigh in, they look at it and said, well, the battery technology is not there yet. They are saying battery technology, and somebody in here must know. What are we? It's not Moore's rule, which was data storage was doing what, doubling every year? Yeah. Okay. So battery technology. Does anybody want to throw out a number for what they think we're going to get annually, as far as improving density on the batteries? Maybe 10 to 12% a year. So everybody is expecting our battery technology to all of a sudden will be going thousands of miles in these airplanes. There are real physical limitations to the evolution of that technology that were not like data storage, unfortunately. So we're saying a 250-mile range. The average Cape Air flight right now, the average is about 120 miles. And from here to Nantucket is like 25 miles. So again, for the short haul, high frequency carrier, this airplane works, provided that you're not trickle charging it for 40 hours every time you fly it. And then runway lengths, the runways at Hyannis are like around 6,000 feet. So we got, you've got good short field capability. The shortest runway that we operate with our conventional airplanes is in Provincetown, which is 3,500 feet. We actually have a sub-fleet of airplanes that we use in the Caribbean that are short field airplanes that operate into Culebra and Virgin Gorda. The reason I keep saying these names is because I'm trying to market a little bit too. So if you want to go to Virgin Gorda, great destination, you can fly on Cape Air to get there. So this is sort of You know, those are some of the operating limitations of the airplane. It is a heavy airplane. When we first, so our replacement airplane, the Italian airplane, fully loaded at gross weight, is about a 7,000 pound airplane, 7,000 to 8,000 pounds. So one of the problems with this is energy density. You know, the weight of the battery in order to have the amount of energy is sort of off the scale, and it really pushes the limits of what is and what isn't possible. When we have battery breakthroughs, you're going to see breakthroughs in electric aviation happen at a much faster rate, because 18,400 pounds is heavier than any airplane I've ever flown. It's a heavy airplane. And from a certification standpoint, they have to keep it under 19,000 pounds to certificate it in the category that they're operating it in, or that they're certificating it in. The useful load, so including this 2,500 gets you to the 18.4, but you've got to move around 18,400 pounds in order just to carry 2,500 pounds. And 2,500 pounds gives us the ability to carry a full load of passengers, 2 pilots, and all of the baggage. One thing we don't have to worry about is the weight of fuel, which is good news and bad news, because right now in our airplanes can carry 1,500 pounds of fuel, but typically we fly around with only 600 or 700 pounds. I shouldn't be telling you that, because now you're going to be looking at the fuel gauge. But we don't have to carry the extra weight in fuel. We can leave it on the ground, depending on how far we're flying. This airplane, we're always going to be carrying the batteries. Right? And then the electric motors, for those who are motor people, and you can go on the Aviation website and check it out. They're 650 kilowatt, well 700 it says, but really 650 is the output, kilowatt electric motors, 2 of those, which will power this. From an environmental standpoint, obviously there's no carbon fuel. From an aviation standpoint, I will tell you much more than fuel emissions. The community neighbor, well, we hear more from our communities, much more than carbon is noise. And so the neat thing about this airplane is it's going to be much, much quieter. I mean, the airport executive here, right? As soon as I say the problem with neighbors is noise, but it is. I mean, around airports, that's sort of the neighborly issue that we deal with all the time. So what we're going to do, phase 1, is we're going to, I'm still trying to convince the manufacturer that they need to do this. What they need to do to launch this technology is to pick a couple of Cape Air cities that are underutilized. We don't do a lot of flying, let's say, between Havre and Billings, Montana. Put a couple of your airplanes on that market and fly them in a non-commercial. Use the Cape Air stations, let us service the airplane, fly them back and forth between our flights, and get the operating experience so that you really understand what the airplane can and can't do and know the airplane. It's amazing how arrogant, they haven't been humble for some reason, manufacturers can be, because they think they're just going to, print the airplane, give it to you, and you're off and running. Remember the first Tesla car? Yeah, that's what's going to happen with any new technology. And you can't afford to sort of, you're not, with an airplane, you're not going to take off and, oh yeah, we better pull over here. So what we have offered the manufacturer is phase 1, which is to put it on a couple of our markets, and we'd like to do it here in Hyannis, because this is where our home is, it's where our technical capabilities are and everything else. So think in terms of, for however long it takes, have airplanes here that are flying on a Cape Air route, but doing it non-commercially, so that we really can get good operating experience with the airplane. And they can learn too. They will have people on the ground where we are measuring everything. The neat thing about modern technology is you can measure just about anything, record it, go back, really mull over the data. It's not trial and error. You really can move fast with it. And then phase 2 is start to scale up and then put the airplane on markets where the airport infrastructure will support the airplane. And when we say airport infrastructure, and when did we apply for this grant that we applied for?
It was like 2 or 3 weeks ago.
2 or 3 weeks ago. We've applied, I think, the airport, I say we, but really the airport has applied in partnership with Mass Department of Transportation for, I think, initially $15 million.
Its first phase is $2 million, and then second phase is implementation, $15 million.
15
And
million.
that was with MassDOT Aeronautics.
And, oh my God, I didn't see you.
Yeah.
How are you? But that's with MassDOT to get the infrastructure built out to support the airplane, because you think, okay, what's the big deal? You know, you fly it A to B and then you plug it in. The technology to get the energy to the airport, to store the energy, and then to get it into the airplane is huge. And because I'm driving an all-electric car, forgive me for going a little bit political, but I no longer even say the name of the car I'm driving until Twitter gets fixed or whatever. So all I will tell you is I'm driving an all-electric car, and as I learn about that car, you know, I can plug it into 120 volts and let it sit there for a week, or I can plug it into one of the stations that they set up all over the country and charge 200 miles in 15 minutes. So what we have to make sure with this is that what the infrastructure and the capabilities are at the airport match what the operating needs are for the airplane. The economics of this get really interesting because, you know, when you're looking at any operation like we are, you've got your fixed cost, right, which is the capital cost of the equipment, and you've got your direct operating cost, which is the cost of fuel, the cost of maintenance, the cost of replacing engines, engine reserve or motor reserve. So you've got your operating costs, which are variable and exist every hour you fly it, and then you've got your fixed cost, which is to purchase the equipment, right? And this cost, the purchase cost, is hugely dependent on flying the airplane a lot, right? Because you've got a fixed cost that you're spreading out over a number of flight hours. So if you buy a $7 million airplane and you fly it 1 hour, it's cost you $7 million an hour to own it. If you fly it 7 million hours, it's cost you $1 an hour. Somewhere in between is a sweet spot, but we have to fly the hell out of this airplane to pay for it, right? Now, part of that cost is going to be what I'm going to show you in a second, which is hopefully a significant reduction in the operating cost. So what that means is if you can take an airplane that has lower operating costs and fly it a whole lot of hours, you can actually take some of that savings and apply it to the fixed cost of buying the airplane. And that's part of the moving target here. So to give you an idea, right now, Cape Air flies about 63,000 flight hours. We average about 40 gallons of fuel an hour, which means we're using about 2.5 million gallons of fuel a year. Average cost per gallon is about $6. And so that's about 15 million bucks. I actually dictated this to someone while I was driving my electric car. I actually could do those numbers in my head. Now I realize that's not that big a deal. I mean, right? It's just not that big a deal. But anyway, if you look at this, your delta here is almost 10 million bucks, right? But that's the whole fleet. That's what, 60 airplanes will be flying. So this bridges some of the gap. You're saving a lot on energy costs, but you're not saving enough to bridge the gap of what the capital cost of the airplane is. And by the way, this is a significant number. What is a kilowatt hour going to cost in 5 years? So this will be interesting to see whether this group is paying attention. 3 years ago, what were you paying for kilowatt hour in your electric bill? Does anybody know roughly?
17 cents.
Okay, these are good numbers, 12 cents, 15 cents. You got to take the bill apart, right? And talk about profit by mystification. People ask me about airline pricing, and I say, well, the reason it's so complicated and you can go one way for $25 and the other way is $2,500 is that the way the airlines do this is it's called profit by mystification, which is if we make it confusing and mysterious enough, you'll give up and you'll stop trying to figure it out and you'll just pay to get somewhere. I'm convinced the utility companies are doing the same thing. When you look at a utility bill, how many line items are there of expense? At least 10, right? And so you've got your production cost, your distribution cost, your renewable energy cost, I've given up on trying to understand it. But yeah, you guys are right. Somewhere between 12 and 18 cents is where the cost of a kilowatt hour was 2 or 3 years ago. Where is it now? I know what I'm paying. I'm paying 35 cents a kilowatt hour at home. When you're running a business that's that dependent on energy, you can't have that kind of variation. And one thing that scares me is the demand that we're going to be putting on electricity over the next 15 years. If you believe at all in supply and demand economics, Matt, do we believe in supply and demand economics? Sort of. But if you believe in that, then you can't think anything other than the cost of electricity. There's going to be a tremendous upward pressure on the cost of electricity. And this scares me. Now, when we first ran the numbers with Aviation, the number they were having us plug in there was 12 cents. So just since we've been talking to them, we are now putting 25 cents in. But I'm going to pressure test our economic model up to probably 40 or 45 cents before we start actually giving them real dollars. Right? We've given them now as a letter of intent to buy 75 airplanes, and we put a bunch of money into an escrow account as good faith. But we can't give them money until we actually see the hard data and understand the economics of it. And obviously we won't, because we're pretty conservative. But this is a huge driver, right, as to whether or not this is a feasible thing. Now, the neat thing is that with offshore wind, for example, where we are actually signing contracts for what the cost of electricity is going to be, it becomes more predictable if you can get a long-term energy price purchase. Now, one of the things, what has the airport done with all of that electricity that the airport is producing?
So we have a 20-acre array, 7 megawatts. 25% of it goes back to the airport, so it's just going to the grid.
Yep.
We're not saving it, and that's what we need to look at, is how do we store that energy with our own system in the future.
So in order for the airport to do what it did, and just tremendous kudos and respect for them doing it, but what they had to do to make their costs and everything predictable is they had to do power purchase agreements that take the electricity in effect off the airport. And one of the things we're going to look to do with the Cape Cod Gateway Airport and other airports is to say, look, whatever agreements you have, we got to figure out how to undo them so that we can keep that energy on the airport and actually rationalize the economics of doing that. Because the model that works here is to produce the electrons on the airport, store them on the airport, and put them into the airplane. It doesn't do a lot of good if you're plugging in an electric airplane and at the other end of that is a coal-burning plant that is, continuing to do mountaintop removal in Virginia. So, really to do this in a way that has integrity is to make sure what you're using to put the electricity into the airplane is renewable, is clean, is nearby, is supported by a grid that can handle it. So that, we are as much into it with that side of it as we have to be with the electric airplane. Because the whole reason we're doing this is not to make things worse, it's to make things better. And this, Jim, could you explain this? Because I can't understand it.
Yeah, well, it's just sort of speculation to try to figure out what would, it's sort of like the last slide, except the last slide was fleet-wide, and this is an example if we flew 12 round trips a day, Hyannis, Nantucket.
So this is a day of using the airplane with using
No,
gasoline.
that's one flight, Dan.
This is one flight versus that. And you can see if you take that delta and you put it into the purchase price, or into the infrastructure, or into whatever, you're bridging the gap.
Have you calculated savings on maintenance? Because you own a Tesla, I own a Tesla. They don't use a lot of maintenance.
When I picked up the Tesla, and Jim drove me up, he was so proud of me for getting an electric car. He
You
takes
still haven't
credit for it.
applied for your Cape Air rebate, though.
No, I'm not taking the Cape Air rebate for that. But it's really, and you had the same experience. I said to them, okay, they took me on a check ride around the parking lot. Didn't really tell me much, but here's your car. And I said, well, where is the manual and what's the maintenance schedule? And she literally laughed at me. There is no maintenance schedule on a Tesla, right? I mean, I don't know one. It's changed the tires when they wear out. Other than that, there is no maintenance schedule. The battery, because of the way that battery is charged in a car, very different than this. The battery will last a long time, and it's sealed bearings. Everything is sort of sealed and long-term. There is no maintenance schedule. So right now we spend, let's say, $300 a flight hour on maintenance. If we can get the cost of the electric airplane down to $100 a flight hour, which I think is doable, then you can apply $200 a flight hour on maintenance towards the purchase price. The electric motor should last 20,000 flight hours. Currently, we change our reciprocating engines every 2,000 flight hours. So if the engine can actually last 10 times as long, you're going to be saving on your engine reserve. But the other side of that equation is the battery. Now, one of the technologies that needs to improve is the battery management, because right now in a Tesla they say never let it get down below 30% unless you can help it, and don't charge it over 90%, because the way to maximize battery life is to do a steady charge, not a rapid charge. Never let it go up to 100%, never let it go to a certain amount. You can't do that with an airplane. You got to charge it all the way up, and on a flight you're going to deplete it below what they like. And when you plug it in, every time you're going to use rapid charge technology, except when you charge it overnight. So the battery cycle in these electric airplanes right now, they're telling us 3,000 cycles, maybe 3 years, and they're very expensive. So even though we may save on the motor versus engine, we might give it back as far as the batteries, expensive. And repurposing them, like leaving them at the airport to be storage units at the airport. There's a lot of innovative ways to continue to recycle those batteries, but that is going to be an issue with these airplanes. I say this with pride because I don't think there's another airport in Massachusetts that has this, right?
Yeah, I don't think so.
Not even close. But the first, not the biggest, the first solar array at the Barnstable Airport was the one I talked to you about. But under Katie's leadership and her predecessor, they worked really hard to build that array, which
That second one's not ours, but these two.
these two, and we'll take credit for that.
Sure, okay.
And what's the total kilowatt?
It's 20 acres, 7 megawatts, for those two units. I'm not sure what your units are.
That's remarkable. And one of the things about airports is there's a lot of open space. So any airport can and should do this, and then should have a model for powering the electric aviation that goes on there, and build internal infrastructure, and then make money selling it. Storage is huge. It's the key to anything we're hearing about electrifying everything, which is, how do we store things in both an environmentally friendly way, but also that works, both the physics and the economics of it work. I'm incredibly proud of this. I mean, this airport environment here in Hyannis is a net producer of electricity. And I don't think there are a lot of airports around the country that could claim that. Massport's doing some great stuff, by the way. I mean, the state of Massachusetts, Commonwealth of Massachusetts, is just doing some fabulous things. And again, I talked a little bit about this, but connecting stakeholders, but understanding the infrastructure needs. Dorothy Savarese, who is the president of the Cape Cod Climate Change Collaborative and the executive board chair here still, and I were both appointed by the incoming governor to serve on her transition team for climate change, resiliency, and adaptation. And we had our first meeting 2 days ago. And one of the neat things about Dorothy being there is she'll be sure that banks get paid attention to relative to climate change. And the neat thing about me being there is I'm going to make damn sure transportation gets paid attention to relative to climate change. And part of that paid attention means understanding, we were asked to write a survey going into the transition team process. And what I wrote in that survey is we really need to understand what the federal resources are, because federal governments can do something that state governments can't. What's that?
Print money.
Yeah, print money, borrow money. And we can borrow money a little bit at a state level, but nothing like the feds can. So in the Inflation Reduction Act, and in still what's left of ARPA funding, the crisis recovery from the pandemic money, there's a lot of money there that we need to really be looking at to apply to projects that are going to get us where we need to be around transportation. Jim and I were out at a conference in August where I almost spent my 65th birthday.
Yeah, and I lost my wallet.
Oh, yeah. We literally disassembled the hotel room so we checked in. We normally wouldn't share a room. We haven't since the night before I got married. We actually shared a bedroom because we had a lot of guests from out of town. And after that night, Jim said he will never sleep in the same room as me again. So, but we got out to the hotel in Colorado and they had overbooked the hotel, so they forced us to stay in the same room. Jim somehow lost his wallet, and I swear to God, we disassembled that entire room like 5 times. They're still probably trying to find the mattresses. Anyway, we went out to this conference, National Renewable Energy Labs, that
is really it's sort of a joint public-private entity. They're under the Department of Energy, but they get a lot of their funding from contracts with private entities that are looking to develop new technologies. It was the coolest road trip because they have a whole campus there where they're, running experiments. There's a washing machine hooked up to like all kinds of weird devices to try to make washing machines more energy efficient. And they're doing a lot of work on transportation too. National Renewable Energy Lab, NREL. And again, that's just an example of what our federal government is and can be doing as part of the transition. And again, there we are, committed to sustainability, growth, and innovation. That's it, right? Because I keep pushing and nothing happens. Okay. So, questions, comments?
Who's funding aviation?
Oh boy, that's, so we haven't talked about the 5 and where we're going to put our tremendous financial success here at the bank. Tom, that is the biggest challenge that we have in this industry. Because the question, I'll preempt the question I'm going to get, when do you expect to launch these airplanes? And the answer to that question is we had a meeting with them yesterday on the phone, and they're telling us this airplane will be commercially ready in 2027. Now that doesn't mean we're not going to see them here, because we're going to need to do proving runs and testing runs and all that kind of stuff. But when we're going to put paying passengers into it, they're saying it'll be 4 or 5 years. So we're talking about patient capital, right? We're talking about people who are willing to make an investment today and not see return for a long, long time. So right now it is privately invested there's one of the wealthiest people in Singapore who's from New Zealand, private investor, has put close to $100 million into this, a guy named Richard Chandler, and he has a company which is investing. They're doing a Class B raise right now. They're out trying to raise money for it. I'll tell you who can't afford to invest in it, even though they've asked many times, is an airline. I mean, we can't make that investment. Airlines are horrible as far as our margins, and we don't have the capacity to do it financially. So they're looking to do a private capital raise in order to fund where it is now to get it to market. So they're looking for private investors. Anybody here wants to do it, I'll give you the contact.
I thought this is unbelievably exciting. I am a 26-year Air Force veteran, and so a lot of the people that I work for and work with are as passionate as you are about flying. I missed the Air Force and the U.S. military on the stakeholder list, and also in terms of funding, what about DARPA? I mean, this is revolutionary. When you talk about what your industry impacts in terms of our use of fossil fuels, it's off the scale. If anyone's tried to calculate their carbon footprint and they do any traveling at all by air, that will outweigh everything else we do. So I just wonder why the U.S. military is missing, and if there's an opportunity, or if you'd be willing to chat with some folks that I think could bring them into the investment part. Because I have, my closest mentors were pilot physicians, Air Force Surgeon General, pilot physician.
So let me apologize.
They would eat this up.
I would first apologize because it should be on there. That is our oversight. That's a presentation issue. It's not.
You're already talking to them.
Oh yeah,
Okay.
because they are partners. They're working with NREL as well.
Okay.
So Department of Energy, Department of Transportation, Department of Defense are really unified around this. They're leaders because, as you know, they're already flying.
They're the biggest airline in the world is the U.S. military.
That's right, and they're already flying UAM, unmanned vehicles, electric vehicles.
And this airplane looks about like the C-21.
Yeah,
which is their executive. I mean, they could be testing it along with you.
They are, and a lot of it is confidential, top secret stuff.
Okay.
So there's a lot of stuff going on that we're not even allowed to know about. But a lot of the drones that are flying, there are a lot of drones that are using conventional propulsion and carbon fuel. There are a lot of drones that are electric right now already. And they are converting some of the conventional airplanes. So if you take a Cessna Caravan, for example, single engine turbine airplane, it's got a payload of about 3,000 pounds. If you're not putting passengers in the airplane, you can actually fill the airplane up with batteries and use an electric motor. The problem with doing that with conventional airplanes like that we use is you've got to have payload to put passengers in.
But if you're not going to be flying passengers, you actually can convert a lot of conventional airplanes to be electric airplanes. And the Department of Defense is doing a ton of work on this.
Great, thank you.
One of the neat things is about this technology, if you're going to like go to remote areas with conventional airplanes, you need to figure out distribution for fuel. You need to get the fuel there, you need to set up fueling infrastructure. All you need to put energy into an electric airplane is a wind farm, a solar array, and a battery. So this is a portable technology as opposed to trying to figure out how to get jet fuel or aviation gasoline anywhere. Yep.
Are there any hybrid airplanes?
Yeah, so the big debate that's going on now is, so we're being approached by everybody now. And there are hydrogen propulsion airplanes, there are hybrid airplanes, and there's a couple of ways to do hybrid. One is hydrogen propelled, the other is using hydrogen to actually drive a generator to actually charge batteries in the air. So there are all kinds of technologies being used. Anything bigger than 9 passenger that you see in the next given existing technology has to be a hybrid, because the battery density will not allow for bigger airplanes right now. So there's a lot of good work being done around hybrid. Yep.
Well, I have a lot of operational questions, but to focus on a couple. What are the implications on pilot training and certification?
Yeah. The certification part, I'll take that first. The certification part goes like in phases. And the first thing you have to do before the FAA is really paying attention is what they did 2 months ago. You have to show the FAA that you have something that actually is capable of getting off the ground. Then you get into the certification phase. The first is called technical certification, which really gets it to a lot of the, sort of the technical issues, the FAA, understanding the systems, the integrated systems, and then it gets to the certification that actually allows the airplane to be used out of experimental category into commercial. So that's why you're talking about a 4 or 5 year process. The next 2 years, they're going to be going through technical certification, and then they're going to be getting into the actual certification. So it is a long process, as it absolutely should be. And one of the things I didn't say is these airplanes are being manufactured under the manufacturing regulation called Part 23. Big airplanes are manufactured under Part 25. So there's 2 very different certification methods and regulations. Part 25, the big airplanes, they're flying around. If I move a control up in the cockpit, it talks electronically to a servo out of the control surface, and then a little electric motor moves it, or a hydraulic pump moves the hydraulics and moves it. Any airplane that's certificated under Part 23 today, when I move the flight controls, there is a cable literally that runs from the control back through the airplane to whatever surface I'm trying to move, and it moves it. It's all controlled by cable. There has never been a Part 23 airplane that is a fly-by-wire airplane. That is to say, it goes through an electric signal and moves the control surface. So it's not just it's not just certifying the propulsion. It's a whole new integrated flight system that needs to get done. So this involves everybody in the FAA. It's a Honeywell flight control system. Right now, Honeywell doesn't put anything into a Part 23 airplane. So this is a Honeywell system. It's a fly-by-wire system. It's an electric airplane. It's all composite, or mostly composite. The de-icing, how you pick up ice if you fly through a cloud and it's below freezing? Well, right now there's 2 ways to de-ice an airplane. One is to inflate little rubber boots at the front, and it breaks the ice off mechanically. The other, which are new, that's what our old airplanes use. Our new airplanes have what's called a TKS system, which has little microscopic holes in the leading edges, and they bleed de-icing fluid while you're flying, and that either prevents ice or de-ices the airplane. This airplane is going to have a completely new technology that de-ices it, which I'm sort of both waiting to see and terrified by. It's actually going to use a vibration technology. So the wings are actually going to vibrate, obviously very minor tremor, which will then break the ice off. So everything about this airplane is going to be really exciting, but new technology. Yeah, exactly. The pilots in the room are going like, I'll stick with the old boots.
What about pilot training? That's what I was thinking of.
Yeah,
retrain
I have to be careful how I say this, because I'm 45 years a pilot, and I love flying airplanes, and I celebrate what it is to be a pilot. but, you know, can we drive our Tesla without, yeah. The truth about it is the pilot training is going to be easier. And what you're really talking about with pilot training is system management versus aviating skills, which I hate because I'm a poet pilot. I love the flying of the airplane. But it's all going to be about understanding systems, but this is going to be a really smart airplane. So if there's anything that's not where it should be, it will tell you, and it will make everything be where it needs to be. And the airplane basically is being designed to be a pilotless airplane, if and when it ever gets to that point.
Cat 3.
Yeah, yes, yep.
What's with the green?
Well, the airplane?
With the blue, you're changing your brand. And the second part is your seagull. I mean, what is that yellow symbol? Does the seagull fly into a prop?
You know, when you come in to be a sustainability department of one at an airline, you're trying to excite some people about the idea. So our marketing person realized when we electrified, you know, we solar electrified, that they wanted to do livery or a paint job on one of our planes that announces that. And so, of course, it was green because it was a green movement, and it has the sun because, and let me say, when I came in 2009, neither Dan nor I nor anybody thought like our exit, you know, at the end of our lives from Cape Air would maybe have an airline that would have no fossil fuel burn. I mean, that wasn't, it was putting solar on buildings and stuff. So that's why the plane, and that paint job was done like in 2011, right after we did our first solar. Yeah. It's still out there.
Okay. I think it says committed to environmental sustainability here, and then it says solar powered headquarters here.
And yeah, it's the wrong color for Cape Air. Yeah.
Since you brought up branding, as I was watching how the corporation expanded in quote small markets, how do you integrate the brand of Cape Air, which is so familiar to us here in the Cape, into Montana? I mean, I can sort of understand in the Caribbean or, you know, in water environments, but what's the overarching branding message across the corporation that allows you to continue to build Cape Air as a brand?
That is, you know, and we spent a lot of time when we expanded into other regions. Like when we went into Florida, we actually called ourselves Key West Express because our main thing was to fly people to Key West, and we rebranded ourselves there, only to find out that most of our customers there flew us around here and were confused as to why we weren't calling ourselves Cape Air down there, because there are a lot of Capes. We went out to the Midwest, it turns out there's a place called Cape Girardeau, and we actually flew to Cape Girardeau, and they were really flattered. They were like, wow, it puts us on the map. So, you know, and in Montana, a lot of the people there know Cape Air from what they have either flown us in the Caribbean or they've flown us here. So, you know, I sort of say Cape Cod potato chips, right? I mean, if your brand is strong enough, and, you know, we fly, you know, between, let's say, 500,000 and 1 million people a year. If your brand is strong enough, you actually really get market presence quickly by bringing that brand there, as opposed to trying to rebrand yourself everywhere you go. I guess that's the easiest answer.
Yeah, but how do you relate? I understand the people who know you from another market, but to build your brand with new customers, you know, how do you make that Cape aura mean something in the Midwest?
You provide great service over time. Wait, are we running out?
You know, I think we could be here all day. I have many myself. Do you have a few minutes to hang out with and answer individual questions with folks?
Sure.
Great. So Dan, thank you.